We humans want to go to Mars, and we already have plans for it. If we want to land our astronauts on Mars, we need to study microastronauts. Yes, you heard that right. Microastronauts are the bacteria that already live in our orbital observatories in space. Our astronauts never travel alone in space. Every astronaut carries about 100 trillion bacteria, viruses, and various kinds of microorganisms on their body with them into space. Many of these are essential for humans, while some are very dangerous. But we still haven't understood how these bacteria react in microgravity environments. And the most dangerous thing is that we still don't know how many types of bacteria live on our International Space Station. But NASA now wants to find this out. Recently, astronauts have collected samples from almost every corner of the ISS. It's kind of like conducting a census of those microbial astronauts so that we can understand them, and if they are dangerous, we can eliminate them or stop them, so that nothing like a sci-fi movie incident happens on the ISS hundreds of kilometers above Earth. Or if there are long-duration missions like going to Mars, how to deal with them. Bacteria are always around us. It is believed that there are as many bacteria on and inside our body as there are human cells inside us. You can think of humans as a moving ecosystem because of them. Scientists believe that most of these bacteria even affect our heart and even our mental health. Scientists often see this microbiome as an invisible organ that works collectively to support the body. That's why it's no surprise that for long-term spaceflight missions, like going to Mars or even farther, studying and understanding this invisible organ is extremely important. Scientists are not only concerned about the human microbiome, the spacecraft also has its own microbiome. In 1998, about 3 years before the Russian space station Mir was deorbited into the Pacific Ocean, scientists found dozens of species of bacteria there that we had never even imagined. They were hiding behind the service panels. At that time, scientists observed this microbiome functioning like a beautiful machine installed on the space station. That microbiome was so alive, almost like that of a human being, and sometimes it can prove dangerous for the astronaut's health. Just imagine, you and your companions are on a long journey to Neptune, and suddenly you find out that there is a bacterium on your spacecraft that eats flesh, so how will you deal with that invisible enemy? And this isn't some crazy idea. In 2006, a team of scientists sent samples of Salmonella bacteria on the Space Shuttle Atlantis for 11 days, just to find out if, when that bacteria returned to Earth, it would kill mice much more easily. And it is believed that the bacteria that live in space are less affected by antibiotics, which is even more dangerous. This will weaken the astronauts' immune systems during long journeys in space. Now that we understand that bacteria are very important for any space mission, it becomes even more important to study them. Exactly. That's why, to reduce any such microbial threat and to deal with them completely, NASA's Jet Propulsion Laboratory has launched a project. In February 2024, astronaut Kate Rubins collected bacterial samples from about 100 places on the ISS. They were kept in cold storage for a few months and then sent to Earth, where scientists will study their genetic signatures and name them. And a three-dimensional map of these microbes will be created, meaning the entire microbiome of the ISS will be studied. It will be observed what kinds of bacteria can be found in which locations. Scientists currently know very little about which specific molecules on the ISS are supporting the growth of bacteria there. We will find out. The map can tell us about the growth of good bacteria, which molecule is connected to which microbe, and that too just by controlling the amount of molecules or nutrients. This will help us understand long journeys like going to Mars. Which materials should be used in the interior of the spacecraft? With this, we will be able to protect our spacecraft from getting contaminated even before our astronauts board it. Kasturi Bankateshurenjo is a microbiologist at NASA JPL. She says, but the process won't be fast there and we will have to deal with this hassle soon. When we go to another planet to send samples back to Earth, we won't have the option to send samples to Earth, nor will we have that much time. Because in any dangerous outbreak, every moment is precious, and we have already seen this clearly during the COVID-19 pandemic. How can a tiny virus cause such devastation across the whole world? The samples that Ruben has collected include two types of samples. While one sample is of microbes, the other sample is of their metabolites, meaning the natural chemical byproducts of that microorganism. This will allow us to link the microbes with their metabolites. And when we have this data, we can create small biosensors that will be able to detect these metabolites. You can imagine a device that you can hold in your hand. Although such detectors may become available in the next 10 to 15 years, you can detect the presence of bacteria or fungi on a spacecraft as well. To prevent outbreaks, cleanliness can be maintained at specific stations, and we will be able to keep these microbial communities much safer. A lot of effort is put in to keep these under control on the space station. Every week, the ISS is thoroughly cleaned by astronauts so that any such outbreak can be prevented. Every astronaut on the ISS spends about 3 hours a week just on cleaning, which means that 6 astronauts spend about 18 hours cleaning the ISS every week. If you look at it, that's quite a lot, but the conditions on the ISS are completely different, where sanitization is very important, because if you drop any kind of food on the space station, it doesn't fall to the floor like it does on Earth, where sanitation is necessary because it can end up anywhere. At the same time, some scientists believe that such a microbiome outbreak is not a major threat to us on long interstellar missions or even on a Mars mission. Their argument is that we have been living on the ISS for the past 2 decades, but till now, not everyone there has gotten sick. Finding a dangerous bacteria is not necessarily a warning sign. We should only be worried when that bacteria actually starts making astronauts sick. We spend about 3 hours just cleaning, but we must be careful not to kill beneficial bacteria out of outbreak fears. This decision should be made cautiously. We should observe how different bacteria react in a stressful environment, and we should make decisions about the ISS based on that. At the same time, some scientists are concerned whether these bacteria might end up in another world. They are worried that these bacteria might go there and destroy it. Another world means the other planets where our astronauts will go, and with them, Earth's bacteria will also go. It takes 3 hours just for cleaning. An ISS astronaut spends about 3 hours a week just on cleaning. Because of this, we might get false positive signs of life on other places. And that's why NASA and other space agencies take a serious approach on this subject. That's why NASA crashed its Cassini-Huygens spacecraft into Saturn, so that no contamination could reach its moons, where there is still a strong possibility of life. Anyway, here the topic is the ISS. The astronauts present will themselves within a week set foot on another planet for the first time, and they will have their own unique microbiome. Also, the spacesuit they are wearing will have its own microbiome as well. If scientists maps that microbiome, then they will be able to choose a better material for that suit, and secondly, they will also be able to clean it in a better way. Apart from this, scientists can also design a better spacesuit from which fewer microbes leak onto another ISS. Apart from this, it ranges from space travel to Mars colonization. But even here on Earth, in our homes, airplanes leave their own microbiome almost everywhere. Here, we can prevent some microbes from growing in space, and we can do the same thing here on Earth as well. For example, tests are being conducted on the efficiency of an antimicrobial coating on the ISS, which was made by Boeing. The idea is that if this coating can work in space, which is much more dangerous than Earth, then it will easily work on Earth as well. Often, space technology makes our everyday lives even easier. But for now, by understanding these bacteria, we can take our space travel to the next level. It's been 6 decades since the last nuclear detonation in Earth's orbit. Conflicts are continuously increasing, many countries are at war with each other, and often tensions rise so much that countries even issue nuclear threats. And it's no secret that in today's world, it's become much easier for some people to access the sun. With just the press of a single button, the whole world can be turned into a battlefield. But for now, these space travels have given a warning that maybe Russia can take nukes into space. When the United Nations Security Council put forward a resolution to ban such dangerous weapons, Russia also voted. Meanwhile, some US officials say the same, that there is currently no such threat. Often, space technology is a part of our daily lives, and currently, there are no nuclear weapons present. However, possibilities make life even easier than Starfish Prime. But for now, by understanding these bacteria, we have made space travel much easier in depth. A catastrophe caused by a nuclear explosion is often made much easier to handle by space technology. First of all, but for now, an initial fireball is formed, which destroys everything within its range. And it destroys buildings over a large area and also causes fires. And finally, we see the iconic mushroom cloud created by the air pressure. After this, a lot of radioactive material falls from the atmosphere, and over a large area, it keeps taking human lives from a few minutes to decades. And finally, what we see is the iconic mushroom cloud. This is the chronology of a nuclear explosion on Earth. But in space, these explosions are completely different. There is no fireball there, no shockwave, and no mushroom cloud. As soon as it goes into space, a nuclear bomb changes completely. In space, this bomb releases all its power in the form of electromagnetic radiation. The nuclear bomb changes completely. In space, this bomb releases all its power in the form of electromagnetic radiation, which includes deadly gamma rays and X-rays as well. 3 waves of mass destruction are released from these. The first is a huge flash, which also includes deadly gamma rays and X-rays. This flash of radiation carries so much energy that any satellites coming into the surrounding area are immediately destroyed due to overexposure to radiation. After that comes the destructive electromagnetic pulse, or you can also call it EMP. It will be released due to the Compton scattering phenomenon, and it will collide with Earth's atmosphere. Electrons will start getting released. These electrons, along with other charged particles from the explosion, will travel along Earth's magnetic field lines, which will give us man-made but spectacular auroras to witness, just like the ones that were seen in Hawaii during Starfish Prime. It depends on the size and altitude of the nuclear explosion as to how much destruction the EMP will cause in space and on the ground. In space, these have the power to damage some unprotected electronics or even cause a complete blackout of the entire Earth. The third and final wave of this explosion will have the longest lasting effect, and secondly, it will prove to be the most dangerous. In an instant, it will create a high radiation zone or a belt in space that could last for months or even years. Due to overexposure to this, satellites will start malfunctioning very quickly. Near our Earth, there is a Van Allen radiation belt where the radiation reaches dangerous levels. Just think of it this way. This nuclear blast will create an artificial Van Allen radiation belt in space in which high-speed charged particles will be moving around. Engineers would never want any satellite or spacecraft to even go near that belt. This extra dose of radiation shortens the lifespan of the spacecraft. The radiation belt created by the Starfish Prime thermonuclear explosion carried out by America in 1962 lasted for years. During this time, it also targeted a satellite named Telstar. This satellite was launched just one day after that detonation. Radiation exposure exceeded normal levels by over 100 times, causing it to malfunction immediately. In the same month, the satellite's operations were halted and the satellite was rendered inoperative right there. Today, there are more than 10,000 satellites orbiting our Earth, some of which are very important and some are extremely expensive. Although most countries, which makes it very difficult to find out. So, can today's low Earth orbit satellites withstand radiation on such a large scale? Which makes it difficult to find out. The problem is that we can't even estimate how massive this destruction could be. Most of the satellites orbiting in low Earth orbit will go offline immediately. This will be an emergency. The whole world will be on high alert, and even satellite communication could be shut down. Flights won't be able to take off. Thousands of flights will be stuck in the air. For example, Starlink, which provides high-speed broadband connections, has around 6,000 satellites in low Earth orbit. If these satellites are damaged, the scale of destruction will be huge. The world could face major economic losses due to satellites. Considering the location and intensity of the blast, astronauts on the International Space Station and China's Tiangong Space Station will be in great danger. The electromagnetic pulse will damage their critical electronic systems, causing their spacecraft to fail, and they will also be constantly at risk from other satellites that have turned into zombies, as there is a chance they might collide with them. Even if there are no software or hardware problems, radiation exposure will take the lives of those astronauts within minutes, hours, or at most a few days. Due to the blackout on Earth, no rescue mission will be possible. Even if none of this happens and our best electronics survive, our atmosphere will not let harmful radiation enter. But still, the global tension generated by this orbital blast could trigger a global nuclear war. Currently, no one knows for sure. It might be just a rumor or a serious secret mission. Russia has seriously considered putting weapons in space. Or we know that all these countries secretly keep working on many projects. It's just not possible that these countries don't have nuclear weapons to deploy in space. Secretly, all these countries have such weapons. The USA is just lying in wait under the guise of being a superpower. Meanwhile, Russia and China are sitting there accusing the USA of this. Ever since Russia announced the end of its ISS partnership, this threat has increased even more. But humanity is not ready for this yet. We don't want the entire human race to be threatened because of one person's obsession. Humanity has already witnessed the destruction of Hiroshima and Nagasaki. A nuclear explosion in space on a scale 100 times greater could wipe us all out. There could hardly be a greater foolishness than this. Either our space will be filled with such nuclear weapons, or humans will wisely find a solution to this. Be sure to share your opinion with us in the comment section below. Friends, how did you like this video? If you enjoyed the video, please like it and share it with your friends. For more such informative videos, make sure to subscribe to the channel and enable the bell notification. We'll see you again with another informative video like this. Until then, stay curious, be happy, and goodbye.